Hello. So in this video, I'm going to talk about solving logarithmic equations. Um, you might see a wire. I'm trying to eliminate or reduce the hissing sound of the back, but doing the best I can. I'm using these little headphones. You might see the wire from it. All right. So these are the steps I use to solve equations, log equations. I move all the logs to one side of the equation, and you just do that by adding the logarithmic term or subtracting it. That's all you do. And the way, if you see the word log, then that term is a logarithm. If you don't see the word log, then that's not a logarithm. You can keep it on the other side. And then I combine all the logs into one single logarithm, right? Using these three properties of logs. And then once I have one single log, I undo the log either by using the definition of the logarithm, which I provide here, or theory, where I raise both sides of the equation by using the same base as the log. And then finally, once the log has been undone, you just use regular techniques of algebra to solve for the variable. And then of course you want to check your answer. You can't take the log of a negative number or a log of 0. Let me just mention why that is. If you recall the graph of a log, this is the most basic graph. So y equals log in base a of x, where a is positive. Well, I'm sorry, a is greater than 1. And this is here, x and y. And what you see here is you don't have any negative numbers. You can't, this graph doesn't even exist here, nor does it touch x equals 0. So you can't have the log of 0 or the log of a negative number. All right. Now, let's go ahead and talk about a couple of these, go through a few examples. So in the first example, I'm trying to keep the same location so you can see the whole piece of paper. All right, let's say you have log of 3x equals log 4 plus log x minus 2. All right, so I got logs all over the place. So I want to move all the logs to one side. I've got two logs here, two log terms here, and one here. I'm going to subtract this one because I only have to do one subtraction. Alright, and so ideally this becomes 0 here, and here you have log 4 plus log x minus 2 minus log of 3x. Now, when you come to this spot here, right, you've already moved all the logs to one side of the equation, and now you want to combine them using these properties. First of all, you can only use the first two properties when you have coefficients of 1 in front of the log, which we do, so that's fine. If you don't, and you have like a coefficient like 5 or something like that, you move it up by using property 3. But in any case, I want to mention that it doesn't matter how many logs you have. Let's say I had log a minus log b squared plus log c plus d minus log k, to the 1/3 power equals 0. All I care about is whether there's a plus sign in front of the log or a minus sign in front of the log. Because if there's a plus sign, then whatever you're taking the log of goes in the numerator. If there's a minus sign, whatever you're taking the log of goes in the denominator. So I'm just going to put all these real quickly into one log. So log, whatever, this is base 10, understood. Your a, right, this has a plus sign, so your a goes in the numerator. This has a minus sign here, so your b squared goes in the denominator. You have a plus sign here, so c plus d goes in the numerator. You have a minus sign here, so this goes b to the 1/3. And there you are. Instead of, I don't suggest doing it piecemeal like students do. They'll do 2 at a time, and then the other 2, and then the other 2. Just do it all at once. It's a lot faster. All right, so here we have then log, understood plus sign here. So we have 4 goes in the numerator. Here there's a plus sign, so x minus 2 goes in the numerator. And you have a minus sign here, so 3x goes in the denominator. All right, now you're done with step 2. Now you want to undo the log, either using the definition or raising both sides of the equation. So let me mention here that the definition, let me compare the two. The definition of the logarithm says the log in base b of x is y. You can only have b to the y equals x, right? So an example of this would be the log in base 10 of 100 is 2 because 10 squared is 100. Okay? Now, where did they get that definition? By using theory. So what do I mean by using theory? Well, you're using the theory of inverses. If I have, let's say, 3x equal to 17, and I want to solve for x, the questions I'm really thinking of are, well, how is the x being affected? It's being multiplied by 3. What undoes multiplication? Division. So you divide both sides by 3. You have the multiplication and division undo each other, and you have x equals 17/3. It's really the same theory applied in terms of inverses when you're talking about logs. I have log in base b of x equals y. What undoes a logarithm? An exponent. So what do? You raise both sides of the equation in the same base. Right? So now this becomes the superscript, right? So here's your main line. This is in superscript. But what happens? You have a log and an exponent undo each other, and you get x equals d to the y, which is your definition. So the definition is something you memorize. Theory is something you understand and use, and you can carry with you. So I use theory where you basically raise both sides of the equation using the same base as the log. It's more writing, I understand that. But 2 classes from now, when you've completely forgotten the definition, the theory you'll carry with you. So I'm here, it's understood base 10 even though it's not written. If I use the definition, I'll say 10 to the 0 equals 4 times x minus 2 over 3x. If I use theory, what I'll do is I'll say 10 to the 0 equals 10 to the log in base 10 of all this stuff, 4 times x minus 2 over 3x. Okay? And now these undo each other, and I've got 10 to the 0 equals 4 times x minus 2 over 3x. And so, of course, you end up in the same place, but like I said, will you remember this? I don't know. This I understand as just undoing, so I carry it with me. All right, so now you have to anything, base to the 0 power is 1, so 1 equals 4x minus 8 over 3x. Therefore, 3x equals 4x minus 8. Subtract the 3x, so you'll have 0 equals x minus 8, and x equal to 8 is your answer, your potential answer. Now you have to go back and actually plug it in. You want to do your check, and your check should be log of 3 times 8. Does that equal log of 4 plus log of 8 minus 2? Right. So basically log of 24, does that equal log of 4 plus log of 6? All right. So let's go ahead and put that in the calculator and see if we get that right. You can see what I'm doing to check. All right, so it's log of 24. Does that equal log of 4 plus log of 6? All right, log of 24 is 1.38, blah, blah, blah. And then the other side is log of 4 plus log of 6. So log of 4, close your, parentheses, plus log of 6. You don't have to close that second one. You can if you want to. Yes, they're the same. All right, so this is correct. Okay. All right. Next problem. Got a lot of paper flying around here. Okay. Log of negative x. What is that equal to? 2 minus log of 6 minus x, and this is all in base 4. Okay, see if you can make this nice and centered. All right, so we're solving this next one. So here again, you're applying the same steps. Now, are there different ways of solving this? Of course, there are always different ways. I'm just giving you the set of steps that I know will carry you through pretty much any of the log equations that we're dealing with. So you're going to move all the logs to one side and then combine them into a single log, then undo the log, solve for x using regular algebra, and then check your answer. Alright, so I have a number here, it doesn't have a log, so I want to keep that on that side. I want to move the other log, which is plus log 4 of 6 minus x. I want to add that to both sides. Log 4 6 minus x. Okay? So now we have log of negative x plus log 6 minus x, and this is all in base 4, equals 2. And now I want to combine them. Since there's a plus sign between them, when I go to say, well, log of base 4 of the single log, it's of negative x times 6 minus x. Because they both have plus signs in front of them, so they go from the numerator. There's no denominator here, or if you want to say divide by 1. Now I can either use theory and say 4 squared is all this stuff, right? So if you want a nice, for the definition, log base b of stuff equals y means that b to the y equals stuff. Okay. So this would be b to the y, so 4 squared equals all this stuff, negative x times 6 minus x. Granted, it's much easier. That's the definition. I say by theory, which you'll carry, you would say 4, you're going to raise both sides, right? And here you're going to have log 4 of negative x times 6 minus x. These undo each other. What are you left with? Negative x times 6 minus x equals 4 squared. Of course, in either place, you get to the same place. So now we have, when we distribute, you have negative 6x plus x squared equals 16. Okay? That's a quadratic, right? Second power. So move everything. So now, here, at this point, you're now done with logs, and you're just back to regular algebra. And regular algebra says, that's a quadratic equation. So you either have to factor, complete the square, or use the quadratic formula. All right, so zeroing on one side, that's the basic technique, right? 0 for quadratic. And here's a, b, and c. You can put it in the quadratic equation formula, right? Or you can factor it, if you can. Not always can you. Looks like this one you can. So you get x equals 8 or x equals negative 2. Now remember, those are potential answers. You still have to check your answer. And when I check it, what I mean by that, when I check it, what I mean is I got to put this back into the original equation. So log of negative x. So if I try, let's say x equal to 8, I'm going to do negative of the x, 8. Does that equal 2 minus log of 6 minus 8? Well, the problem is you're taking the log of a negative number. So x equal to 8 is not an answer. Right? Can't do it. So now you got to check the other answer, x equal negative 2, and see if that works. So log base 4 of negative over negative 2. Right, that's your original equation was negative x, so negative over negative 2. Does that equal 2 minus log in base 4 of 6 minus a negative 2? Right, we want to know. Alright, let me make sure you can see this. Okay, you can. So this is log base 4 of 2. Does that equal 2 minus log in base 4 of, 8. Right? Alright, now, here's the thing. On your calculator, you don't have base 4. You have 10 and e. So you have to do a change of base. So if you remember, change of base, formula, they'll say log of base b of x is equal to log of x over log of b. So this is some base that you don't know, like this, 4. Right? You don't have it in your calculator. And this is the base you do have when you only have 2 of them, 10 or e. So this could be base e or 10. So basically you're taking the log of the number over log of the base. Log of the number over log of the base. So in this case, I'm going to change this into a log that I can use, base 10 or e. I would say log 10 of 2 over log 10 of 4. So log of the number over log of the base. Does that equal 2 minus log base 10 of 8 over log base 10 of 4. Okay. So let's go ahead and do that. All right, log 2 divided by log 4. That's this part right here. What's that equal? 0.5. So 0.5 does that also equal 0.5 here. So now 2 minus log 8 divided by log 4. Yes. So there you are. That works. You could also do ln. You could do ln 2 over ln 4. Does that equal 2 minus ln 8 over ln 4? And I'll let you do that in the calculator and see that yes, it works. Okay. So I think we're good there with this problem. All right. Next one is ln x minus 4 plus natural log x plus 3 natural log x minus 13. Let me make sure you can see all that. Yes. All right. So remember, ln is same as log base e. Right. I just don't write it that way. All right. So I got all logs. Bring all the logs on one side. So natural log x minus 4 plus natural log of x plus 3 minus natural log of x minus 13. And of course, when you do a lot of these, you'll just go right to the log already made together like this. You'll have, this is understood to be a plus sign, so this is x minus 4, x plus 3, because that's a plus sign, and then a minus sign, so this goes here, x minus 13. There. Now this is understood to be log base e. So by definition, you do e to the 0 equals all that stuff or by theory, you would do this. Raising both sides. These cancel out, you're left with this. So again, of course, you're going to be left with the same thing. Like I said, I can prepare this much more than the definition. So now you have e to the 0 is 1. So this is actually 1. So then I'm going to multiply both sides by x minus 13. So 1 times x minus 13 equals here under the FOIL. So x squared minus 4x plus 3x minus 12. So x minus 13 equals x squared minus x minus 12. Now let's bring it over. So it's a quadratic. So minus x is minus 2x. Minus 13 plus 13 is plus 1. And when you do factor this, this is x minus 1 squared. So x equals 1. Now, when you go to plug this back in, if I put 1 in here, it won't work, right? Because I'll be taking the natural log of negative 3. It can't take the log of a negative number. And that's the only potential answer we got. So what's the answer? No solution. There are no solutions to this. That happens. And our last example log x minus log 7x minus 1 equals 0. All right, logs are already on one side. I need to bring this coefficient up, and I need to use property 3 to move that 2 up here. Right? So I'll have log x squared minus log 7x minus 1 equals 0. Now I can bring them together. Oh, that's a log, right? So I'll have, this is understood to be up here in the numerator. This is in the denominator. Now, this is understood to be base 10, so you could say 10 to 0 is x squared over 7x minus 1, or you could use theory. 10 log x squared over 7x minus 1 equals 10, 0. Okay, so now you'll have 1 equals x squared over 7x minus 1. So then you'll have 7x minus 1 equals x squared, and finally x squared minus 7x plus 1. And this is a quadratic, and it cannot be factored. You could try, but you're going to have to use like quadratic formula or completing the square. And so you'll have this. And what you'll end up getting is, you'll get at 0.1459, or x equals 6.8541. And if you plug it in, if you plug each of these values in here, right, you'll get a true statement. It will check out correctly. Make sure you can see the whole page. Yep. And that is our last example. Thank you so much for listening.